Okay, so here we are on our first set of notes. And just remember when you're doing your notes at home, we're going to do these notes together so you understand how you need to have them done. But when you're doing them at home, make sure you write down everything that I have on the notes and make sure you write down any questions you still might have. Okay? So this is section 1-1, prime factorization. And our essential question on this is, how can I break down numbers into smaller parts to discover all of its factors? So, so let's talk about that a little bit. Okay, so the first thing we need to do is do some vocabulary. I'm going to zoom that in. Okay, so first thing are our factors. So factor is a number. So factors are numbers you multiply together to get another number. Okay? Remember, the great thing about flipped notes is that you can always hit pause, and if you need time to fill that in, you hit pause, get all your notes down, and then hit play again. Okay? All right, multiples. What's a multiple? A multiple is a number that can be divided by another number. Okay? And let's put in here evenly, meaning it has no remainder. Okay? All right, our next vocabulary word is a product. And a product is the result of multiplication, basically, right? You multiply two numbers together, that's a product. You multiply 10 numbers together, that's also a product. Okay? A prime number is a number that can only be divided by itself and 1. Okay, and I'll give you some examples of prime numbers in a second. Okay, so is a composite number is a number that can be divided by a number other than 1. Okay? So let's think about those for a second. Okay? An example of some prime numbers would be, let's put some in here, 17, 13, those are prime numbers. You can't divide them by anything else. 41, okay? Composite numbers, anything that's can be cut in half. So 12, 25. Most numbers are composite numbers, okay? So let's go over and think about what prime factorization is. That's probably something you've heard of before, but all it means is breaking down a number into its smaller pieces. So think about a recipe. Think about if you're making a chocolate cake. You have the flour, the eggs, the oil, the cocoa, the sugar, right? You have all the different pieces that make up a recipe. That's all a number is, and it's broken down into different pieces. Okay, so let's think about the number, let's say 36. Okay, and there's lots of ways we can get to 36, right? We can do, let's see, 3 times 12, 1 times 36, 2 times 18, 4 times 9, and 6 times 6. Lots of different ways we can get to the same product of 36, right? So prime factorization just means breaking it down into its smallest numbers. We're going to do some practice in class on that. So we'll hold off on that for now, but breaking it down into its smallest pieces. Anytime you see a number that is not broken down as far as it can be, that's going to be when you are going to try and get that number smaller. So 12 is a composite number, right? You can do 3 times 4 or 2 times 6. 4 is a composite number, 2 times 2. 9 is a composite number, 3 times 3. So anytime you have a number that can still be broken into smaller pieces, you want to keep going until you're all the way down. Okay? So let's see which factors are the most helpful and what are their rules. So let's just think about those. Let's think about the number 2. Or, yes, 2. Okay? So any even number can be divided by 2. Right? You can cut it in half and you won't have anything left over. Any number that's divisible by 3, if you add the digits up and you can divide by 3, that number is going to be divisible by 3. 4 is the last 2 digits can be divided by 4. Another way to say that is the last 2 digits are a multiple of 4. So 4, 8, 12, 16, 20. Okay? 5's, that the last digit is 5 or 0. Okay, those are going to be your easiest. 6, 7, 8 get a little bit more interesting, but we'll talk about those a little bit more in class. Okay, so how can I find the prime factors for the following numbers? So let's start with 175. So anytime I see a multiple of 25, I start to think, okay, let's see how we can break this down. Anytime I see something that is a multiple of 25, I think of money. I think of quarters. So I think, how many quarters would it take me to get to $1.75? So 100 is 4 times 25, right? And 75 is 3 times 25. Okay? So I have 25 times, took me 4 plus 3 to get there, to its times 7. So now ask yourself, is 25 a composite number or a prime number? Well, I know I can multiply 5 times 5 to get 25. So then I add that 7 on the end. And another way you can write this, I'm fine with you leaving it just like this. Another way you can write this is when you multiply a number by itself, that creates an exponent. So I have a 5 and I have 2 of them. So that becomes my exponent times 7. I am totally fine with either one of these. Okay? And when we do the con skills, we'll go over how you need to enter those in the con skills. Okay? All right. Let's try 235. Again, think about what you have. Okay? You can break this number down into numbers that are easier to deal with. So 235 is the same as 200 plus 35. I bet you can figure out ways to multiply those together, right? So 35 is 5 times 7. And I know that 5 can also go into 200. So 5 times 4 is 20. But I've got 10 times that much, so I've got 5 times 40. So your common number that you have between those two is a 5. So we're going to do 5 times, and you're going to add these two together. So 5 times 47. And you can't break that down any farther than that. 47 is a prime number. It's only divisible by itself. And you're done, just like that. Okay? Let's go over to 344. Okay? So remember our rule of 2s. You could start with 2s because this is an even number. But our rule of 4s is if the last number is divisible by 4, then the whole thing is divisible by 4. So think about what that is. That's 300 plus 44, right? And 44 is divisible. That's 4 times 11. So I want you to think about hundreds, okay? So if you have 100, that can always be broken into four. If you have $1, you have 4 quarters, right? So you have 3 of those right here. You really have 100 and 100 and 100. If I take that 300 and just move it down here, right? So, oops. Each one of those is 4 times 25, 4 times 25, and 4 times 25. The easiest way to think about that is now you've got 3 at 4 times 25, and you have the plus the 4 times 11, right? Let's move that up a little bit. Okay. So the common guy you have in there is the 4. So you have 4 times 11, and then 4 times 3 times 25. The only number in there besides a 4 that I can break down is the 25. So I've got, what can I break 4 down into? Well, that's 2 times 2. And I've got a 3, and I've got an 11, and 25 is 5 times 5. Okay? So now I've got all down to prime numbers. 2, 3, 11, and 5 are all prime numbers. So I've got 2 2s, a 3, an 11, and 2 5s. Okay. In a lot of our class we're going to be doing, you're not going to have to use prime factorization a whole lot, but you do need to know how to break down numbers to make them work for you in other situations, which is one of the reasons we're reviewing this concept. Okay? All right, and last one is 256. So automatically you see that that is an even number on the end. Even numbers are 0, if they end in 0, 2, 4, 6, or 8. So I know, so let's say that you don't know any number that goes into 256 and you're having a hard time breaking that down. So one thing you can always do is cut that in half, okay? And I'm going to show you a way to do division that I think is a little bit easier than doing long division. I'm not really a fan of long division. So watch this, okay? We're going to turn everything into a fraction. Even though we're not into fractions yet and you may not like fractions a whole lot, watch this. I want you to take each one of these one by one and see if 2 goes into 2, right? So right there, does 2 go into 2? Yes, it goes in one time. Do you have any left over? Nope. So now the 2 is done. Now you're going to go to the next number, which is 2 into 5. Does 2 go into 5? Yes, 2 goes into 5 twice. 2 times 2 is 4, but I have 1 left over from the 5. So I'm going to put that 1 right there. Okay. Now, does 2 go into 6? Yes, 2 goes into 6. Oh, sorry, I'm sorry. 2 goes into 16 8 times. Okay, so far I've got that 256 is 2 times 128. Okay, that's still kind of a big number, but again, it's an even number, so let's cut that in half. So what? So 2, and now I'm going to cut this one in half. So I've got times 2. 2 goes into 12 6 times, and 2 goes into 8 4 times. Okay. Now at this point you might see that 64 and go, oh, Miss V, I know that I have that on my multiplication sheet, and I know that 64 is 8 times 8. Okay. So now I think, well, 8 I know I can cut in half, so that's got my first 2's out there. Each one of these 8's is 2 times 4. Well, 4 is 2 times 2. So now I've got 2 times 2 times 2 for each one of the 8's. Times 2 times 2, plus my original 2's that I had in the front. Now we just have to count. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 2's. So my base is 2, and I have 8 of them. Okay? So there's some examples, and again, we'll do it in class. But so at the end of your notes, every time you're doing notes, I would like you to kind of summarize what you have learned from that section of notes. So, for example, I want you to know that the factor is the part of a number, and the multiple is the whole part of the number. Okay? We can break multiples down into factors, and we can make factors become multiples. Okay? That's the end of the first notes.